We're here to talk about how do we value a stock. We know now how to value bonds, and what are some of the general models, generic models for valuing stocks. The general case, just in general, you're going to see that stocks are much more difficult to value than bonds. There are several models. We don't know a lot about the stock as much as we do about the bond. The bond, we know the face value is $1,000, and we know the required rate of return of all of the bonds in the market. So a lot of knowns in the bond world, but in stocks, we just don't know if a company will pay a dividend, when it will pay the dividend, when it might begin to pay the dividend, and how long the dividend will continue. And we don't know the stock price in the future to discount those back to today to get a handle on the stock price. So, and we're going to go over several cases that will help us to value stock. There are many, many others that are a lot more complex. These are very good general cases. First of all, what I'm going to call the general stock valuation equation, I'll call it wildly fluctuating. It's where dividends are all over the place. They may grow at a supernormal rate for several years and then step back to a more normal rate. So we're going to call that one the wildly fluctuating or general stock valuation model. It's the first equation you see here. Another equation you should memorize is the zero dividend growth case. So what happens if GM, who used to pay $2 a year, continues to pay $2 a year forever? So $2, $2, $2, $2. We know that that's an annuity. Hopefully it will go on forever. We know in GM's case it hasn't. They've stopped paying their $2 dividend due to financial difficulties. But if there were a company to come about that would pay a constant dividend every year, same amount each year, that becomes an annuity. If it goes on forever, it's perpetuity. And we remember from Session 6 that present value of perpetuity is C over R. So here we just substitute the dividend value in there and you get D over R for the stock price today. If we have a constant dividend growth, McDonald's recently announced that they are going to pay a constant 4% growth in dividends. Try to anyway. That was their model and their plan. And so if we have a constant dividend growth rate G, we know that the price of the stock today is equal to the next dividend over R minus G, where G is the constant growth rate in the dividends. We'll talk more about that model. If we have supernormal growth, again, where a company grows very, very fast to begin with and then starts to level out, we go back to the general stock valuation equation, or what I call wildly fluctuating, where the present value or price of the stock today is equal to the future dividends discounted back to today, plus some price of the stock at some time t discounted back to today. And finally, the two components of required return we want to memorize, D1 over P0 plus G. So if we switch around that constant growth equation for P0 and solve for R, we get the required return of any stock. What do you want when you buy a stock? You want dividend yield plus capital gains yield, and those are the two required elements of required return. Looking at our learning objectives, we have 3 for this chapter. We want to know and learn how to value common stock. We're going to go through some of those models. What are some of the features of common stock and preferred stocks, and how are they different? And finally, where do we buy our stocks? And the answer on the stock markets, and we'll go over some of the stock markets. Common stock valuation is a little bit more difficult than bond valuation, as I've said. We don't have any promised cash flows whatsoever, unlike a bond where you have a promised coupon. You don't know if the company will be in financial difficulty or not. The life of the investment is forever. You hope the corporation goes on forever. So there is no maturity date, unlike a bond, which has corporate bond has a 30-year maturity date. There is no easy way to look at the required rate of return as you can with the bond market, so a little bit more difficult to value. So what is the price of the stock today? It's equal to present value of the dividends plus some price in the future, all discounted back to today. And we can go on and on, discount all the dividends back, dividend 1, dividend 2, dividend 3, dividend 4, dot, dot, dot. And if we push out that P sub T, the price of the stock out far enough, it kind of falls off the map because it's discounted by such a large factor that there isn't much value. So we could say in general, the price of the stock today is equal to the present value of all of its future dividends in a very simple model. Model number 2, again, that's the general stock valuation equations. If we have no growth in dividend, as I said, the price today is simply equal to D over R, which looks like a perpetuity equation, C over R, from session number 6. So same amount each year in dividend. The price of the stock is simply the dividend divided by required rate of return. In model number 3, constant dividend growth model, we have a constantly growing perpetuity. We have a growth rate, a constant fixed growth rate that's declared by the company, and therefore we can look at the price of the stock today as being next dividend D1 over R minus G. Another way to look at the price of the stock at any time T, like P15 is equal to D16 over R minus G. Again, next dividend over R minus G. If we have some information on the price today, the stock price today, then the price at any time T is simply price today times 1 plus G to the T. And it looks very much like the present value, future value equation. In general, in this dividend growth model, the price of the stock at any time T is equal to next dividend over R minus G. So again, if we want to do a P4, price of the stock in time 4 is equal to D5 over R minus G. Price of the stock at time 10 is equal to D11 over R minus G. And this only applies when dividend is growing at a constant rate G, like in the case of McDonald's. They've recently looked at a 4% targeted growth rate. This works mathematically if the required return is greater than G. So we don't have a negative denominator. Supernormal growth rates can exceed the required return over some future length of time. Again, a company may grow very, very rapidly. And again, we have to go to, when we see this, when we see what I call a wildly fluctuating dividend model, we go to equation number 1, and that is the general stock valuation equation. When I'm looking at P sub T out there to the right, we know it's equal to dividend sub T plus 1, or dividend at the next growth rate divided by R minus G. So P sub T, what I do is I step back 1 year. So if it says that the dividend will grow constantly in year 4, then we go step back to year 3 and calculate P sub 3, and P sub 3 is D4 over R minus G, and that takes care of all future dividends, almost as if it were P0 out there. And again, so sometimes these stocks will grow at, let's say, 30% very quickly when the company is starting up and growing rapidly, and then taper off to like a 5% more common and reasonable growth rate. Again, if that happens in year 4 where the growth goes constant, we step back and calculate P3 at the end of that equation, and P3 is equal to D4 over R minus G. Components of required return look at what do you require when you buy a stock. Well, hopefully you get some price appreciation and your stock goes up. This is referred to as capital gains yield, and if it's a constant growth rate, can be you can use the terminology G, same as the growth rate in dividends. And dividend yield is D1 over P0. So when I buy a stock, hopefully someday it will pay me a dividend. And the dividend yield, breaking up that constant growth model into pieces, gives me dividend 1 over P0. So percent R is equal to D1 over P0 plus G, dividend yield plus capital gains yield. And that's what I look for when I buy a stock.